Hello, good evening everyone. Am I audible? Is my video is clear? Good evening everyone. Yeah. Good evening everyone. I am Shambhavi, your physics master teacher. I'll be taking some parts in physics along with Catherine ma'am and Supreet sir. Okay, so if my audio and video is clear, please let me know. So let me check in phone as well. Okay. So I think it's fine now. So today we will be starting with a new chapter. You're already done with motion in a straight line, units and measurement. So in today's session, we'll be starting the new chapter, that is motion in a plane. Okay, so previous class what and all you have learned, it's about units and dimension or units and measurement. Okay, how to express a physical quantity, what are all the units for them, correct? So that you have learned. And next you have moved to motion in a straight line. That means the particle motion is constrained to one direction. Okay, so what you have learned, you learned about motion in a straight line, that is just about the particle moving or constrained to move in one particular direction or one dimension, we can say. So the next part is motion in a plane. Okay, so this is more realistic because in our daily life or day-to-day life, if I say, we will be dealing with motion in a plane. If you observe the vehicle movements, so it's more in a plane, it's not in one dimension, right? It's x coordinate, it's y coordinate, will be changing. So motion in a plane is more realistic. Okay, or we can say like two-dimensional motion. Okay, so let us quickly see what are all the subtopics we'll be learning here. So one is, first of all, just little bit of introduction, and then we are having scalars and vectors. Okay, before going actually into the motion in a plane, we had to learn little bit about scalars and vectors, or more precisely more about vectors. Okay, so that is multiplication of vectors by a real number. Then we will be learning addition and subtraction of vectors, graphical method and analytical method. So there are two methods which we have to learn, and then we will be moving to resolution of vectors. Okay, so there is one concept called as resolving of vectors, so that also we had to learn. Then we will be learning about motion in a plane. Okay, so after learning the basics of vectors, we will be learning about motion in a plane, and then motion in a plane with constant acceleration, and then we will be learning projectile motion, and then uniform circular motion. So these two are the best examples for motion in a plane. Okay, so after vectors we will be moving to motion in a plane, and there we had to learn in detail about projectile motion and uniform circular motion. Okay, so this is the basic subdivision in this chapter. Okay, so is it clear till here? Yeah, so can someone respond? Hello Priya. Hello Padma. Yeah. things clear till here? Okay. So it's just the introduction. What are all the topics that we will be covering here? So moving ahead to something called as scalars and vectors. Okay. So can someone tell me what is a scalar? Yeah. What is a scalar? I think in the last chapter also you may have learned little bit about scalars. So can someone tell me what is a scalar? What type of physical quantity we call as scalar? Yes, can someone tell me? Can you respond in chat? I'm just waiting for your response. Yeah. What is magnitude? Somebody is asking. Okay, let me tell you. So, see here, magnitude means, okay, first I will define scalar, then I will tell you what is magnitude. Because in scalar, they are the physical quantities which are having only magnitude. Correct? Only magnitude. The physical quantities which are having only magnitude. So, ಈಗ question magnitude andre ಏನು? So, for example, I will say there is a block. Okay, there is a block. And let us say its mass is 2 kg ಅಂತ ಹೇಳ್ತೀನಿ. So, what is this 2 kg here? This is nothing but magnitude, its value. Okay. So, we measure the physical quantity, it has some quantity in it. So, that quantity we call it as magnitude. Is that clear? Yeah. So, somebody, I think Padma Banu, right? Yeah. So, somebody asked like what is magnitude? It's the amount of that particular physical quantity we are talking. Okay. For example, I say something like force. Force is a vector. Okay. I say force of 10 Newton. So, what is this? This amount we call it as magnitude. Is that clear? Yeah. Correct. Yes, Chetan. It's something you can call it as size. Or, absolutely you can say like the size of that particular physical quantity. Okay. So, I think that is understood now. So, the next is vectors. Vectors andre eno? So, I think somebody already mentioned like magnitude and direction. Okay. So, the physical quantities which are having both magnitude and direction. Okay. The quantities which are having both magnitude and direction, we call them as vectors. But ishte heladre sakagalla. So, we have to add one more condition here. Okay. So, what is that? It is the vectors are the quantities which follow or which obey, okay, vector addition principle. Okay. So, vector addition, they will follow vector addition. Vector addition principle. Okay. So, vectors andre, yeah, usually we say which has both magnitude and direction. But don't stop there. You had to add one more condition, that is they obey vector addition principle. Okay. Is that clear? This is very essential. Just because yavado one quantity ge direction ide, magnitude ide and matrakke we cannot say like vectors. Okay. Vectors will be those quantities, other addition or subtraction if you do, they should follow vector addition principle. So, alli ಎರಡು rule ಬರುತ್ತೆ. ಒಂದು triangle law of vector addition. Okay, it can be triangle law you can say, or it can be parallelogram. There are two which you are going to learn in ahead. Okay, parallelogram law. So, either triangle law of vector addition you can say, or parallelogram law of vector addition you can say. Okay. Is it clear till here? So, scalars andre only magnitude, vectors andre magnitude and the direction. Okay. So any doubts, or if you understood, please let me know. Yeah, can you respond? Yes. Okay, I think there will be slight lagging, so I'll be just need to wait for your response. Okay, fine. So I think we can move ahead, or we'll just mention some examples. Can someone quickly tell me some examples for scalars? Some examples for scalars. Yeah, any examples for scalars and vectors? Could someone specify? Yeah, length, mass, time. So we just say, in terms of their magnitude, some 10 kg, 20 kg mass, 10 centimeter length, 100 meter, like that we just mention their, quantities or the size. Correct? There is no direction is important. But whereas come to vectors, yeah, velocity, and then we have acceleration. Okay, velocity, acceleration, and then we can say force, many quantities, many more. You can list, whatever the vectors now till now, and anyway by the end of first PUC and second PUC will be coming across with many vector quantities as well as scalar new quantities. Okay, yeah. Speed is a scalar quantity. Somebody is saying speed. Speed is a scalar quantity. Velocity is a vector quantity. Okay. In speed we just specify how much is the speed. We don't talk about the direction, or in which way the person is, or in which direction the speed was. We never mention. But when we put speed plus its direction, then we get velocity. Okay, so which is a vector quantity, like that you should understand. Okay, speed with the direction is going to give you velocity. Is that clear? Yeah. So shall we go ahead? Any doubts still here? Yeah. So next is how to represent a vector, because we already understood now that there is two different types of physical quantities are there, scalars and vectors. So I may be specifying about some vectors, but I should, if someone else is reading that, or if someone else is referring to that, they should be able to understand that I am talking about vectors and not scalars. Okay, so there is a standard method which we follow to represent a vector. So as I already told you, so vector andre enu magnitude irutte. So adakke ಏನು ಮಾಡ್ತೀವಿ, so we scale it, the magnitude of the vector to a line segment, and it is also going to have a direction. So what we do, we put a arrow. Okay, so this is how you represent a vector. So I can say AB vector. Okay, so AB vector hege represent ಮಾಡ್ತೀರಾ? So you draw an arrow line, or I can say directed line segment. So this direction will tell you the direction of the given vector. Okay, yeah, and ಬರಿಬೇಕಾದ್ರೆ ಹೇಗೆ ಬರಿತೀವಿ? So it is like AB vector. If I say like AB vector, from now onwards you should not to write like AB vector. What you should do? You have to write AB on top of the variable you have to put an arrow. Okay, so any vector variable hege represent martivi. So let me say some vector variable v vector or a vector or p vector or q vector, whatever, any vector you take, force vector. So let us say f vector. Okay, so nothing but force vector. Is that clear? So any variable on top of that variable, if you put an arrow, so that is how we represent a vector. Okay, so vector na hege represent martivi, a variable with an arrow on top of it. Is that clear till here? Okay, so that is how you represent a vector. Okay, so next is, if I consider any vector, let me say some v vector. So idralli ಏನು ಇರುತ್ತೆ, we know that it is going to have some magnitude. Okay, so vector ಅಂದ್ರೆ ಏನಿರುತ್ತೆ, ಒಂದು ವೆಕ್ಟರ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇರುತ್ತೆ, ಅಲಾಂಗ್ ವಿತ್ ದ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ನಾವು ಯಾವುದೋ ಒಂದು ವೆಕ್ಟರಿನ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ನ ಸ್ಪೆಸಿಫೈ ಮಾಡಬೇಕು ಅಂದರೆ ಹೇಗೆ ಬರಿತೀವಿ? ಸೊ ದೆರ್ ಇಸ್ ಟೂ ವೇ ಟು ರೆಪ್ರೆಸೆಂಟ್. ಸೊ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎ ವೆಕ್ಟರ್ ಕ್ಯಾನ್ ಬಿ represented like this. Okay, so ಹೇಗೆ ಬರಿಬೋದು? Just put the modulus and inside that write down the even vector. Okay, so this is one way. Or if I just say like this, this is also going to represent the magnitude of the vector. If you don't write the arrow, okay, it is understood we are only talking about the magnitude of the given vector. Okay, is that clear? Yes, any doubts? Or we can move ahead. One quick response, I'll just wait for a few seconds. Okay, is that clear to everyone? Yes, hi Aishu, hope you are following. Okay, so this is about the representation of a vector. So illi direction part I'll tell you in a little while. Okay, so how to represent a direction of a vector, there is one particular way. So I think now it is clear how to represent the magnitude of the vector. Okay, so ಏನು vector andre hege ಬರೀತೀವಿ? So any vector is represented like this, v vector, like this. Okay, you write the variable and put an arrow on top of it. So magnitude of the vector andre hege ಬರೀತೀವಿ? Either we just write the variable or we just a second, yeah, so either we write the variable or you put the modulus. Okay, so these two will represent the magnitude of the vector. Okay, yeah, and then we have, there is one more method of representing the vector, that is the bold letters. Okay, so I can say if let me just write here itself. So if we are having a bold letter, okay, so if you observe your NCERT book, okay, so ಅಲ್ಲೇ ಏನಾಗಿರುತ್ತೆ, ಎಲ್ಲ ವೆಕ್ಟರ್ಸ್ನು ಬೋಲ್ಡ್ ಲೆಟರಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ನಮಗೆ ಬರಿಬೇಕಾದ್ರೆ this is not so convenient. Okay, while writing, to bold it separately, to scribble it, it is not so convenient. So what we do, we use this method. So book alli enadru bold letter idre, so please understand they are talking about the vector, not about any scalar. Even though there may not be the arrow, just bold letter means also it's a vector. Okay, is that clear? Any doubt? Yeah. So any doubts, please ask. So I hope there are no doubts. I'll just move ahead to the next thing, that is representation of some vectors. Okay, some the vectors which we usually use, how do we represent, and types of vectors as well. So this is very important, that is position vector and displacement vector, which we will be using now and then. Okay, we will be using now and then. So position vector andre ಏನು? So the name itself is telling, right? Position, it is telling us the position. Position of what? Some particle which we are interested. Okay, so ಏನಾಗಿರುತ್ತೆ position of the particle with respect to the origin. That is important. Okay, position of the particle with respect to origin. So a vector which gives the position of the particle with respect to the origin, we call that as position vector. So let us consider the simple diagram which is given here. So illi enagide, we have our origin here. Hope you can see that. Okay, so enide illi origin ide. Okay, and we have our x axis here, y axis here. Let us say at some given instant the particle is present at this point P. Enagide, the particle is at this point P. Okay, so now if I draw a line from origin to the given point P. Okay, so this is going to give me the position vector of the particle at that time. Okay, so ಏನು ಹೇಳ್ಬೋದು, at some time t position vector ಏನಿದೆ OP vector ಅಂತನಾದರೂ ಬರಿಬೋದು, or I can say something like R vector. Okay, yeah, OP vector or R vector ಅಂತನಾದರೂ ಬರಿಬೋದು. So this is nothing but position vector. You draw a line from the origin to the given point. Okay, so that is should be the direction. Arrow ನಿಮಗೆ ಇಷ್ಟ ಬಂದಂಗೆ ಹಾಕೋ ಹಾಗಿಲ್ಲ, it should be from origin to the given point. Okay, yeah, and next after some time let us imagine the particle is is under motion and it has reached this point P dash. So ಏನಾಗಿದೆ, after some time the particle has reached P dash. So ಈಗ if you want position vector ಹೇಗೆ ಬರಿಬೋದು, so again from origin to the given point I should draw a line and arrow is from origin to P dash ಇರಬೇಕು. So this is our R dash, the new position vector. ಏನಂತ ಹೇಳ್ಬೋದು, OP dash ಅಂತ ತಗೊಂಡ್ರೆ. So this is also nothing but R dash vector. So these are all the position vectors. Yes, okay. Yes, good evening Anvesha, right? Yeah, hope you are also following. Yes, yeah. So any doubts please ask. So now displacement vector, next yadu now we will be using again and again, that is displacement vector. So can someone tell me what is displacement, because you have already learnt in motion in one dimension. So what is a displacement? Can someone tell me? Yeah, I'll just wait for few seconds so that I may get a response from your end. What is a displacement vector? Displacement ಅಂದ್ರೆ ಏನು ಹೇಳಿ ಸಾಕು, ವೆಕ್ಟರ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಆಮೇಲೆ ನಾನು ಹೇಳ್ತೀನಿ. No response. Anybody? So displacement ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡಿದ್ರಿ, it is the shortest distance between the initial and final position, right? It is the position of the object ಅಂತ ಯಾರೋ ರೆಸ್ಪಾಂಡ್ ಮಾಡಿದ್ದೀರಾ. Yes, Chetan, you are right. The shortest distance between the initial and final position along with the direction. Correct, exactly. So ಈಗ displacement na vector notationally represent ಮಾಡಬೇಕು ಅಂದ್ರೆ ಹೇಗೆ, so let me just consider here. So ಏನು ಹೇಳ್ಬೋದು ಇಲ್ಲಿ, so we had our R vector, R dash vector. So the displacement is from P to P dash, right? So this is our displacement vector. So P to P dash in line segment idala, that is our displacement vector. Okay, yeah. So as you said, it is the shortest distance between the initial and final position along the direction of the motion ತಗೋಬೇಕು. Okay, so that is going to give us the displacement vector. Okay, yes Chetan, very good. So I think we can go ahead to the next concept. Hope no doubts in position vector representation and displacement vector representation. Any doubts? Please raise there itself. So I'll move ahead to the types of vectors or the different terminologies which we'll be using, and we'll try to define them. Okay, the very important one is unit vector. Yadu unit vector. So unit vector andre enu? So basically unit andre ಏನು meaning? It is nothing but 1 ಅಂತ ಅಲ್ವಾ. So unit andre 1. So ಇಲ್ಲಿ we are talking particularly about a vector, yeah, which is having magnitude as 1. The magnitude of the vector is 1. So that is what is a unit vector. Okay, yeah, thanks for your response. Yeah, so what is unit vector? It's the vector having unit magnitude. Magnitude 1 ಅಷ್ಟೇ, ಜಾಸ್ತಿ ಅಲ್ಲ, only 1. Magnitude of the vector is 1, always 1. We call them as unit vector. Okay, so ನಮಗೆ unit vector ಯಾಕೆ ಬೇಕು ಅಂದರೆ it is important to specify the direction. ಯಾವುದೋ ಒಂದು ವೆಕ್ಟರ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಬರಿಬೇಕು ಅಂದರೆ ಡೈರೆಕ್ಷನ್ ಬರಿಬೇಕಾದ್ರೆ we can take the help of unit vector. ಸೊ ಹೇಗೆ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? ಕ್ಯಾಪ್ ನೋಟೇಷನ್. ಓಕೆ, ಸೊ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಹೇಗೆ? representation of unit vector is placing a cap on top of the variable. Andre, so for example, I have a v vector. Adara direction or unit vector beku andre hege baritini? V cap anta baritini, or something like n cap, a cap. Yavade vector ina top ali, if you put a cap notation, that will tell you it's a unit vector. Okay, so unit vector representation hege? So it is like placing a cap on top of it. Okay, so ಈಗ with this unit vector, okay, so we have one more standard unit vector representation which we had to learn. So I'll just draw here itself, so which is very important, please remember. So you should not get confused later if I use it. So usually representation ಏನಿರುತ್ತೆ? V cap, n cap, or something like a cap, whatever. Okay, so like that we are going to write. Now if we consider our rectangular coordinate system, so rectangular coordinate system andre ಏನು? X, Y, Z axis, correct? So we have our X, Y and Z axis. Okay, so illi there are 3 standard unit vectors we consider. Okay, so that is I cap along y axis, j cap along y axis and k cap along z axis. Okay, 3 standard unit vectors irutte. Yadu I cap, j cap, k cap along x, y and z axis. Okay, so yadu I cap along x axis, j cap anta bardre ಏನು? It is understood that the direction of the vector is along y axis. K cap anta nodidre ಏನರ್ಥ? The direction of the vector is along z axis. Is that clear till here? Yeah, so I'll just give you one small problem. Okay, it's not a big problem, it's just a simple one. So I'll say there is a force, okay, of magnitude some 50 Newton, let us say, acting along x axis, acting along x axis ಇದೆ. ಇದರ vector representation ಬರೀರಿ. Okay, I want you all to write down the vector representation of 50 Newton acting along x axis. Can someone respond in the chat? Yes, so I'm just waiting for your response. Yes, Sharmila, hope you are following too. So I want you to write down 50 Newton of force along which is acting along x-axis. Adara vector representation beku nange. Rectilinear motion. Somebody is asking what is rectilinear motion. So rectilinear motion is nothing but, you know, moving along a straight line. We usually one dimensional translatory motion will be there, no? That itself we call it as rectilinear motion. Linear, okay? So rectilinear, the word linear itself is there. So rectilinear motion andre eno, it's nothing but one dimensional translational motion, okay? Yeah, so let me just tell you, hope you have tried with writing down this vector. Yes, very good. So 50 I cap, somebody has responded it as 50 I cap. So F vector will be equal to 50 I cap, correct. So 50 I cap, okay. Similarly, if I had some, you know, other vector along y axis, how do I write? So its magnitude into corresponding, you know, unit vector notation, okay. So that's how we had to represent a vector. So if I just quickly go back to my previous slide where I said that we are, you know, considering the direction. How do we going to represent the direction? By unit vector. So complete vector notation irbeku andre enu, adara magnitude matte adara unit vector idre, so that is going to, you know, create the proper representation of a vectors, okay. So magnitude plus the unit vector. Yes, so I think we can go ahead. Yeah, please remember these three basic unit vector, I cap, j cap, k cap, okay. Sometimes only with these three, you know, unit vectors we may leave the cap, okay. Some books they may, you know, drop the cap of I, j and k. That's fine, it is clearly understood. I, j, k stands for x, y, z axis unit vectors. That's a standard notation, there should be no doubt, okay. Yeah, so next is zero vector or null vector, okay. Yavadu zero vector or null vector. So the name itself is telling something is zero or null, which means their magnitude is 0, okay. It's a vector whose magnitude is 0. We call them as zero vector or null vector, okay. For example, a person goes in this direction for some 5 meters, comes back in the same direction again 5 meter. So what is the total displacement here? 0, right? So displacement is a vector quantity. How do we represent? So 0 vector, so usually represented by O with a vector, okay. So origin is also a 0 vector, okay. The 0 vector is actually not going to have any specified direction, okay. It's of arbitrary direction, but its magnitude is 0 always, okay. Hope it is clear till here. Yes, think we can go ahead. Any doubts, please rise or give me a thumbs up so that I consider that you understood it. Yeah. So some other, you know, vectors which often we'll use, that is negative of a vector. So this is important to learn. So in order to understand with the, you know, the subtraction and all, we need how to represent a negative of a vector. For example, I gave you a vector like this. Let me say a vector. It is like this. So now a negative of a vector is going to have the same magnitude, and the length of this line segment must be same, but it will be acting in the opposite direction. So this is going to be your minus a vector. Enagirutte, same magnitude, opposite direction, okay. magnitude same irutte, direction opposite idre, we call that as a negative of a vector. Okay, so that is how we represent a negative of a vector. So the next is co-initial vector. Okay, so yavadu next co-initial vector. Again ille ಒಂದು word ಸಿಕ್ಕಿದೆ ನಮಗೆ, initial ಅಂತ. ಅಂದ್ರೆ so initial point same ಇರುತ್ತೆ. Okay, the vectors which are having same initial point or origin are called as co-initial vector. Okay, so the next is co-terminus vector. Co-terminus ಅಂದ್ರೇನು, their terminal point or ending point same ಇರುತ್ತೆ. Okay, ಏನಾಗಿರುತ್ತೆ, ending point same ಇರುತ್ತೆ, co-terminus vector. Next is collinear vector. So collinear ಅಂದ್ರೇನು, again ಇಲ್ಲೇ ಇದೆ ನಮಗೆ linear ಅನ್ನೋ word, correct? So the vectors, two or more vectors lying along the same line are called as collinear vectors. Okay, so next is coplanar vectors. Okay, so coplanar andre again ಏನು, same plane, the two or more vectors if they are lying on the same plane we call them as coplanar vectors. Okay, so hope it is clear till here. Any doubts, please rise. No doubts? Okay, so what are all the types of the vectors that we have discussed? Unit vector magnitude 1 irutte, null vector magnitude 0 irutte, negative of a vector magnitude same irutte, direction reverse irutte, co-initial vector initial point same irutte, co-terminus vector the vectors which are going to have the final terminal point as same. Okay, two or more vectors which are having same terminal point are called as co-terminus vector. And then we have collinear vector, that means two or more vectors acting along the same line irutte. Coplanar vector, vector in the same plane, two or more vectors lying in the same plane are called as coplanar vectors. Okay, so hope it is clear till here, so we can move ahead. So there are two more way of classifying the vectors depending on the direction. Okay, so depending on few other parameters we broadly classify all the vectors into two categories. One is polar vector anta classify ಮಾಡ್ತೀವಿ, the other one is axial vector. Okay, so polar vector andre ಏನಾಗಿರುತ್ತೆ, these are the vectors okay which are having starting point or a point of application. So ಏನಾಗಿರುತ್ತೆ, ಈ vectors ಗೆ starting point ಅಥವಾ point of application ನ ನಾವು define ಮಾಡಬಹುದು. Okay, we can see from where exactly the the starting point of the vector. Okay, so they are called as polar vector. Okay, usually these vectors are along the direction of the motion irutte, or I can say along that line of motion irutte. It can be along the direction or opposite to the direction irutte. Okay, but we can clearly say okay what is the starting point of this vector, or exactly at which point this vector is acting, like at what point we are applying a force, what is the displacement, like that we know it, right? Yeah, so they are called as polar vectors. Okay, so yavadu displacement, velocity, acceleration, force, okay you can keep on adding, so they are called as polar vectors. Okay, so next yavadu axial vector. Axial vector andre it is something related to rotational motion or rotational effect. Okay, rotational effect ಗೆ relate ಆಗಿರುತ್ತೆ. So ಇಲ್ಲಿ these vectors are going to be along the axis of rotation ಆಗಿರುತ್ತೆ. ಏನಾಗಿರುತ್ತೆ, axial vectors are going to be acting along the axis of rotation ಆಗಿರುತ್ತೆ. Okay, it will be acting along the axis of rotation. So illi rotational motion na ನೀವು when you study so there you will clearly understand what are all these quantities. Angular momentum andrenu, angular velocity, I can say torque, all these are acting along the axis of rotation. Okay, the particle will be showing some rotational motion. Just imagine the motion of the ceiling fan ಏನಾಗಿರುತ್ತೆ, so they will be fixed rotational motion irutte. So alli if you try to find out something called as torque, angular velocity, so they will be acting perpendicular to the the plane of where the object is there, or you can say like it is along the axis of rotation ಆಗಿರುತ್ತೆ. Okay, so that is about your axial vector. So these are some terminologies which we will be using in vector mechanics. So we will just move ahead to the the mathematics with vectors. Okay, yeah, one more we can define, that is equality of vector as well. So that is, let us say there are two vectors, I will say I have given with two vectors A and B. So let me say A vector is like this, okay, and B vector is like this. Okay, so two vectors ಏನಾಗಿದೆ, A vector and B vector, and we can clearly see that they are parallel. Okay, so two vectors can be called as equal if and only if their magnitude and directions are same. So ಇಲ್ಲಿ ಏನಾಗಿರಬೇಕು, magnitude and direction of the vectors must be same. This is very important. Magnitude ಮತ್ತೆ direction ಎರಡೂ ಸೇಮ್ ಇದ್ರೆ ಮಾತ್ರ we call them as equal vectors. Okay, yeah. So if I have a vector here of some magnitude, let me say I may have another vector here B, but still they are parallel. Okay, so then I can shift it, right? So let us say their magnitudes are same, so I can shift it parallelly and I can say okay, these two are same vectors only, correct? Yeah, magnitude same ide, direction same ide, so we can say them as equal vectors. Okay, yeah. So vectors are, most of the vectors what we use, no, they are all free vectors. ಏನು ಹೇಳ್ತೀವಿ, they are all free vectors ಅಂತ ಹೇಳ್ತೀವಿ. Okay, free vectors ಅಂದ್ರೇನು, we can shift parallelly, we can shift the vectors parallelly. Okay, so that is the meaning of free vectors. Most of the vectors are free vectors. There are some localized vectors are there, but we usually don't discuss here. Okay, in our class, first PU or second PU, we usually stick with all the free vectors. You can shift them parallelly. Okay, and hence if their directions and magnitudes are same, we can call them as equal vectors or equality of vectors. Is that clear? Yeah, hope we can go ahead. One quick response, can someone respond? Yes, can someone respond in the chat? So moving to the, yes, so moving to the next concept, that is multiplication of vectors by a real number. So here we are just discussing the multiplication of a vector just by a number. We are not talking about vector to vector multiplication. That comes in the later chapter, which is very important. Yes, yes, thank you Chetan, and another person, I don't know the name here. You can name yourself properly. Okay, yeah. So multiplication of vectors by a real number we are discussing here, but vector to vector multiplication is also there. There are two types of vector to vector multiplication. One we call it as dot product, and the other we call it as cross product, which is very 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 important, which comes in the subsequent chapters, and you had to remember all those things till the end of your second PUC or your competitive exams. The same comes in maths also, don't worry. Okay, you learn all these vector products in maths as well. Yeah, in physics also it is there, but in this chapter we will stick ourselves to a simple multiplication of vector with a real number. It's just by a number, we are multiplying by a number. Okay, we have a vector A, let me say I am multiplying it by something like 10. So ಏನಾಗುತ್ತೆ, now we will get some new vector, let me write it as B vector. So this is going to give me something like 10 times of A vector ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ, ಮ್ಯಾಗ್ನಿಫೈ ಆಗುತ್ತೆ, ವೆಕ್ಟರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ವಿಲ್ ಬಿ ಮ್ಯಾಗ್ನಿಫೈಡ್. ಓಕೆ, ಸೊ ಏನಾಗಿರುತ್ತೆ, ವೆಕ್ಟರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ will be magnified. ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮಾತ್ರ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ ಆರ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು, ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ವೆದರ್ ವಿ ಆರ್ ಮಲ್ಟಿಪ್ಲೈಯಿಂಗ್ ಬೈ 10 or 0.1. It need not to be always magnified. Okay, we can understand like it is, the magnitude is being changed. Direction remains the same. Okay, so direction change agalla. Yeah, so this is about vector multiplication by a real number. Okay, for example, let me take again the force example which we took. So we are having a force of 10 Newton, let us say, okay, along some direction. So I'll just say like some 10 I cap only we will take. Okay, unit is Newton, so right now I'm not just mentioning here. So F is 10 I cap is there. Now I multiply by, or let us imagine like we have increased the force by 5 times. 5 times ಮಾಡಿದ್ವಿ. So ಆಗ new force ಏನಾಗುತ್ತೆ, let me take some new force small f will be equal to 5 into 10 I cap ಆಗುತ್ತೆ, which is going to give you 50 I cap ಅಂತ ಹೇಳ್ಬೋದು. Okay, so this is what is a multiplication of a vector by a real number. So it is not at all going to change anything with respect to the direction, but the magnitude will be changed. Okay, is that clear till here? Any doubt? Yes, Sunita and Revati, I guess. Hello everyone. Yeah, so hope you are following. Any doubts, please let me know. If it is clear, give me a thumbs up so I can go ahead. Okay, so this is a simple multiplication by a real number. As I said, there is even different types of multiplications are there, that is like vector to vector multiplication. Okay, if you multiply a vector by a real number, it is always going to give you a vector. Okay, so vector ge real number inda multiply madidre nimge vector barutte, but two vectors na multiply madidre there can be a scalar or there can be a vector. Yes Chetan, thank you. Okay, so that is how the difference type of vector multiplication is. Okay, so next coming to addition of vectors. Okay, so this is very very important, another very important topic, that is addition of vector. So illi already ಎರಡು ಮೆಥಡ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ದೀನಿ, ಒಂದು ಗ್ರಾಫಿಕಲ್ ಮೆಥಡ್, ಇನ್ನೊಂದು analytic method. Analytic method let us learn little later. So first we will learn about the graphical method. Okay, so basically addition of vectors andre enu, it is trying to let us say we have two or more vectors. Okay, the equivalent we had to try to find out an equivalent vector, a single vector basically, which is going to give us the same effect as the given vectors. Okay, I may had two or more vectors. I want to find out a single equivalent vector which can be able to produce the same effect. Okay, so that is what we call it as addition of vector. A single vector na enanta karitivi, resultant of the given vector anta karitivi. ಏನು ಹೇಳ್ತೀವಿ, resultant of the given vector. Is that clear? So two vector addition ಮಾಡಿದ್ರೆ we will get a single vector which is going to give us the same effect. Okay, and our single vector na resultant of the given vectors anta karitivi. So find out the resultant of vectors andre enu, you should do addition of vectors. Okay, so what you are supposed to do, you have to do addition of vectors. Okay, so there are two methods basically. One is triangle law of vector addition, the other one is parallelogram law of vector addition. So please pay attention, these two are very important concept. Okay, triangle law of vector addition, parallelogram law of vector addition. So one by one consider mana. Okay, so what is this triangle law of vector addition, or ee method alli vectors na hege add ಮಾಡ್ತೀವಿ. Okay, so let us learn one by one. So I'll give you the statement at the end. Okay, So before that, what I will do is, I will tell you what exactly the method we follow here. Okay, first we will understand and later we will learn the statement. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, so we are going to have two vectors anyway we have to consider because we are adding two vectors. So let us say A vector is there and B vector is there. Okay, so ಇಲ್ಲಿ A vector andre, so let me say somewhere like this is our A vector, and B vector na somewhere I will say it is in this direction. Okay, so this is our B vector. So ಇಲ್ಲಿ ಒಂದು point I should tell you, that is this part of the vector is called as tail of the vector, and this arrow we call it as head of the vector. Okay, so ಒಂದು vector ಅಲ್ಲಿ, so let me just write here. So this is the head of the vector and this is the tail of the vector. Okay, so that is you should know. So because this triangle method is also called as head to tail method. Okay, ಏನು ಹೇಳ್ತೀವಿ, head to tail method. So ಈಗ ಇಲ್ಲಿ ಎರಡು ವೆಕ್ಟರ್ ಇದೆ, random direction ಅಲ್ಲಿ ಇದೆ. So what I had to do is, I had to shift one of the vector such that head of one vector coincides with the tail of the other vector. ಏನು ಮಾಡಬೇಕು, we have to shift any one of the vector. Let me say I will shift this B vector. Okay, so I will shift this B vector parallelly so that the tail of B vector fits on the head of A vector. So I will draw the diagram here again. So ಏನಾಯಿತು, so this is my A vector and parallelly shift ಮಾಡಬೇಕು ನೀವು. Okay, any vector can be fixed parallelly, that is allowed because they are all free vectors. Okay, so just imagine that I have shifted this parallelly, so it comes somewhere like this, I can say. Okay, yeah, so slight agi slant ತಗೊಂಡಿದ್ದೀನಿ. I will just say this is our A vector and let us say this is my B vector, so that head of A vector is coinciding with the tail of the B vector. ಈಗ ನಮಗೆ ಇದೆರಡರ ರಿಸಲ್ಟೆಂಟ್ ಎಲ್ಲಿರುತ್ತೆ, so now if I complete this triangle by taking the third side in the reverse order, ಇಲ್ಲೇನಾಗಿದೆ tail to tail coincide ಆಗಿದೆ, ಇಲ್ಲಿ head to head coincide ಆಗಿದೆ. So this is going to give me the resultant of the vector. ಏನಾಗಿರುತ್ತೆ, so we are taking the given two vectors as the two sides of the triangle taken in the same order. That is important. Okay, what we are doing, we are taking them in the same order. Resultant ಏನಾಗಿರುತ್ತೆ, reverse order ಅಲ್ಲಿ ಇರುತ್ತೆ. Okay, so ಈಗ A vector plus B vector will be equal to R vector ಆಗಿರುತ್ತೆ. Okay, A vector plus B vector will be equal to R vector ಯಾವಾಗ, if we represent the vectors by the two sides of the triangle taken in the same order, then the third side of the triangle taken in the reverse order is going to give us the resultant of the two vectors. Okay, is that clear till here? Any doubt? Yes, any doubts? If some doubts are there, talk to me here, mention in the chat. So coming to the statement part, statement ಹೇಗೆ ಹೇಳ್ಬೋದು, triangle of vector addition, if two vectors are represented by two sides of a triangle taken in same order, then third side of the triangle taken in reverse order represents their resultant. Okay, so ಇದಕ್ಕೆ ಒಂದು simple diagrammatic representation ಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡೋಣ, so I will say I have a vector, I have this B vector, ಏನಾಗಿದೆ ಇಲ್ಲಿ head to tail coincide ಆಗಿದೆ. So this is called as taking in the same order. Now resultant ಎಲ್ಲಿರುತ್ತೆ, so by joining the third side of the triangle or closing the triangle taken in the reverse order. Okay, so this is going to give me A vector plus B vector is equals to r vector. So this is one of the graphical method to find out the resultant of the vector. Okay, one simple work kodtini, just let me know, can you able to apply this triangular law of vector addition. So instead of randomly considering the vectors, let me say I have a coordinate axis xy, it's a plane. Okay, so previous diagram e tagolona, enagide the particle p was here and then the p was here. Okay, so I'll say this is my origin, this is p, this is p dash. Okay, yeah, so here you just need to tell me, this is r dash vector anta bardidvi, this is r vector, this is our displacement vector. I'll say something like delta r. Okay, so ಈಗ vector addition rule na use ಮಾಡಿ, can you get me what is displacement with the proper observing the arrows. Okay, so proper agi observe ಮಾಡಿ, you need to tell me what is going to be the displacement vector. Hope you can see a triangle here. Yes, OP, P dash is a triangle. I have given the arrows, I can just remark it. So this is the direction of OP vector, this is OP dash, and this is our displacement delta. So ಈಗ triangle law of vector addition na use ಮಾಡಿ, get the relation between r, r dash and delta r. Simple question. Next ಎಲ್ಲ ಕಡೆ use ಮಾಡ್ತೀರಾ ಇದು. You should know how to write displacement vectors or delta r, delta v, okay, delta a, all those things will be writing down. So please let me know how can I write delta r by using triangular law of vector addition. Can someone tell me? Shall I just wait for a few seconds? Yes, anybody? So ಏನು ಮಾಡಬೇಕು, you have to observe which two sides of the triangle are in the same order. So their sum is equals to the third side of the triangle taken in the reverse order. Correct? So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ I can say I have this r vector plus delta r is in the same direction. I can say r vector plus delta r will be equal to r dash vector. Yes or no? I can write like that. R vector plus delta r is equals to r dash vector, or from here the displacement delta r is equals to r dash minus r. This is how we write down the displacement vectors. Okay, so arrows are very, very important. Okay, one simple homework I'll give you, I'll just give you two vector, a triangle with the vector representation. You need to let me know how they are connected, okay, by applying triangular law of vector addition. I'll say I have a vector here and b vector, this is my a vector, and I say I have my c vector here. Okay, so you need to apply the triangular law of vector addition and you need to get the relation between these a, b, c vectors. Okay, or I can say one more like this, and then we may have one more diagram like this. So let me say this is my a vector, this is my b vector, and this is my c vector. So your job is to obtain the relation between a, b, c by using triangular law of vector addition method. Okay, is that clear? Shall we go ahead? Any doubts? So I'm just waiting for your response. Any doubts? And if you can answer this now itself, it's well and good, and hope it is clear while writing the displacement vector as well. So moving to here itself, I would like to talk about subtraction of vectors. Okay, it's just one step different from your addition, so I am just including it. So if I had to, say I had to subtract two vectors, let me say there is a vector and there is this b vector. I had to subtract these two vectors, means what I should do, it is like I can write it as a vector minus b vector I should do, or this is equivalent in saying a vector plus of minus b vector, correct? Mathematically one and the same, saying a minus b is equals to a plus of minus b vectors, correct? It's one and the same, correct? So because I am considering minus b vector, because I know how to get the negative of a vector. If there is a vector, how to get the negative of that vector, just change the direction, reverse the direction, okay? Then you just add according to your triangular law of vector addition. So that is how we do subtraction of vectors, okay? So if I just had to tell that, so let us again consider two vectors a and b. So I have this vector a in this direction, and let me say my b vector is in this direction. Now I have to subtract it. So what I should do, I need to find out minus b vector. First job is to find out minus b vector. So if this is my b vector, where will be minus b vector? Exactly in the ulta direction with the same magnitude. So this is minus b vector, okay? But ಈಗ triangular law ಪ್ರಕಾರ can we just add them directly? ಇಲ್ಲ, ಯಾಕೆ? ಇಲ್ಲೇನಾಗಿದೆ, tail to tail coincide ಆಗಿದೆ. So we had to shift this parallelly, shift, okay, shift parallelly, okay, so that head of one vector coincides with the tail of the other vector. ಇಲ್ಲಿ tail to tail coincide ಆಗಿದೆ. So ಏನು ಮಾಡ್ತೀನಿ, I'll just redraw this diagram. So our a vector is in this direction, this is our a vector, okay? So ಈಗ ಏನು ಮಾಡಬೇಕು, we had to, let us imagine, shift this here, something like this it will come, correct? So it comes something like this, I can say this is my minus b vector, okay? So what is it? This is minus b vector, and now, yeah, so here I could clearly say head of a is coinciding with the tail of b there. Now if I take the third side of the triangle in the reverse direction, so this is, okay? So illi tail to tail coincide ide. So this is going to give me the difference of the two vectors. So I can say I'll just choose that as c vector. You can choose any vector, okay? I am just representing it as c vector. So hege baribodu, c vector, okay, let me just write top, you may not be able to see this. So hege baribodu, here we are having c vector is equals to a vector minus b vector, okay? So subtraction of the vector by triangular addition method andre ಏನು ಮಾಡ್ತೀರಾ, so consider the given two vector, find the negative of one of the vector which needs to be subtracted, okay? And then just follow the triangular law of addition, that is join the head to tail of the a vector and minus b vector. The third side taken in the reverse order is going to give you the the subtraction of the two vectors, okay? Is that clear? Hope no doubts. Yeah, so I think we can go ahead to the next important concept, that is parallelogram law of vector addition. So yavadu parallelogram law of vector addition, very 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 important. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, parallelogram law of vector addition ಅಲ್ಲಿ, so again we will consider two vectors and we are trying to find out the resultant of these two vectors, okay? So we have two vectors a and b, let me just represent it. So ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ, let us say I have A vector and I have B vector. So the given two vectors are represented as the two adjacent sides of the parallelogram such that their tails are intersecting or coinciding. Illi tail to tail join madirtivi. Okay. So eega we'll imagine or we'll try to construct a parallelogram. So hege I just need to draw a line parallel to A vector and the other side will be B vector parallelly, correct? So this is how we represent a parallelogram. Now if I draw the diagonal, okay, so enagide, if I draw the diagonal of this parallelogram from the point of intersection of A and B, that is the common point or the tail intersection point, I am going to get the resultant of A and B. ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ two vectors na two sides of the parallelogram ಆಗಿ represent ಮಾಡ್ತೀವಿ. Now the diagonal passing through those two adjacent sides are going to give me the resultant of the vector. So again R vector is equals to A vector plus B vector. Okay. So ಇಲ್ಲಿ ಏನು ಹೇಳ್ಬೋದು, observe ಮಾಡಿದ್ರೆ this is nothing but the other form of triangular law of vector addition only we are talking, because this is B vector and by maths we know that this is the opposite sides are equal in a parallelogram. So this will be nothing but B vector, correct? And now I can say A vector plus B vector is giving me R vector, because A vector in a head is coinciding on the tail of the B vector, and I can see a triangle here. Let me just mark this point as something like P. Okay. So ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಈ triangle ನ observe ಮಾಡಿದ್ರೆ I can still say A plus B is equals to R vector. Okay. So it is nothing but the other form of your triangle law of vector addition. Okay. R vector is equals to A vector plus B vector, where A and B are the two adjacent sides of the parallelogram and R is representing the diagonal of the parallelogram which is passing through those two sides. Okay. Both in terms of direction and magnitude. Okay. The direction of the resultant will also be in this way and the magnitude is also going to be represented by the diagonal of the parallelogram. Is it clear till here? Yeah. So we'll just quickly have a look about the statement and yeah, any doubts? Yes, somebody message like hi. Put your names, proper names, instead of randomly mentioning some random names. You can put your own names, so it will be easy for us to call your names instead of calling X, Y, Z. Okay. So coming to the statement, which is again important for your 2 mark, I can say, if two vectors acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram drawn from that point, then their resultant is represented by the diagonal of the parallelogram drawn from the same point. Okay. So we can just refer to the previous diagram. So enagirutte, two vectors are represented by two adjacent sides of the parallelogram, then the diagonal is going to give us the resultant of those two vectors. Okay. So just construct the parallelogram, draw the diagonal. Okay. So this is our R vector and I can say R vector is equals to A vector plus B vector. Okay. Hope it is clear. Any doubts? Please respond once. If it is understood, give me a thumbs up so I can go ahead. Okay. Hope no doubts. I'll just wait for a few seconds so that I can get your response. Any doubts? No doubts? Yes. Okay. Fine. So, the next concept we will be discussing is, this is another important question, I can say. It can be asked in your 5 marks or 3 marks derivation, or the formula what we derive in this we will be using in till the end of your competitive exams. It can be your second PU competitive exams. Okay, so till the end of second PUC and competitive exam, this formula will be using, and you had to remember. It is not that you learn this year and you forget next year. No, you had to remember till second year. I mean, after second year, till the end of your competitive exam. Okay, so that's what I mean to say. So this is very, very, very important. For now, it can be a 5 mark and 3 mark question as a derivation. Okay, along with that, it can be a question. The formula, in terms of formula, it is very, very, very important in each and every chapter. You just check in each and every chapter, we'll be using this formula. Okay, so ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, expression for magnitude and direction of the resultant of two vectors acting at a point. So what we are trying to derive here, we are trying to find out the expression for magnitude and direction of the resultant. Okay, so two vectors, if it is acting at a point, what is the expression for magnitude and the direction of the resultant vector? So in simple words, we are trying to find out the resultant vector. Okay, so hege ಮಾಡ್ತೀವಿ? So this is by using parallelogram law of vector addition. Okay, so I'll just draw here one more time so that you get the comfort of drawing what are all the things are represented in this diagram. But we'll stick to the the same notations as well, so that there will be no confusion. And once we are comfortable in drawing, I'll just stick with this diagram. Okay, so let us say we have two vectors A and B, and it is given that they are acting at a point. Andre enagide, they are acting at the same point. Okay, so that they have a common intersection point, and that will tell me that I should use the parallelogram law of vector addition, so which becomes easier for us. Okay, so enagide, we have A vector here and we have B vector here. Okay, now if I want to find out the resultant, I know by graphical method, I know it's nothing but the diagonal that passes through these two common points, right? The diagonal of the parallelogram that passes through these 2 points. This is the resultant. I know that because just now we learned parallelogram law of vector addition. So if I had to do A vector plus B vector, I get this R vector, which is the diagonal. Okay, A vector plus B vector is equals to R vector. But this is in terms of the graphical method. I have to measure, I need to know what is the magnitude of it. Just every time to go up with this graphical method is not so easy. Okay, to get the actual magnitude of the resultant or to find out the direction, every time to stick with the graphical method is not so helpful. So we have a different method there. So here these two vectors we are considering, they are acting at an angle theta. Okay, the angle between A and B ಎಷ್ಟು ತಗೊಂಡಿದ್ದೀವಿ, theta ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. Okay, and we are also assuming the angle between resultant and A as alpha. Okay, angle between resultant vector and A vector na alpha ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ, angle between the given two vectors na theta ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. Okay, so now we had to find out what is the length of this diagonal. There is nothing but your the magnitude of the resultant vector, right? So we had to find out the length of this diagonal. So hege ಮಾಡಬಹುದು? So for that we will just do one construction. So what I will do is I will extend this A vector, okay, and I will drop a perpendicular from this point. So ಏನು ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಒಂದು perpendicular na drop ಮಾಡಿದ್ವಿ. Okay, and also some other naming we have used. So this is O, this point we have marked as P, and this intersection point we have marked as N, and this will be Q, and this point is S. Okay, so O, P, Q, S and N. So right now I don't want this, later we'll consider that. Okay, so this is the simple diagrammatic representation. So enagide, so we have two vectors A and B are represented by the parallelogram to adjacent sides. Okay, and we have labeled like A vector and B vector, and the angle between those two vectors we have taken it as theta. So this is about the diagram part. Okay, so now we'll try to find out the magnitude by simply using Pythagoras theorem. Okay, the same diagram is here, so I am just sticking to the same diagram. So ಇಲ್ಲಿ ಏನಾಗಿದೆ, we are supposed to find out what is the magnitude of this resultant vector. Correct, ನಮಗೆ magnitude of this resultant vector ಬೇಕು. So ಅದಕ್ಕೆ ಏನು ಮಾಡೋಣ, first we'll consider the triangle ONS. So ಏನು ಮಾಡಿದ್ದೀವಿ, we are considering the triangle ONS. So ಅಲ್ಲಿ Pythagoras theorem apply ಮಾಡಿದ್ರೆ ಏನು ಬರಿಬೋದು, so I can say like OS square is equals to ON square plus SN square ಅಂತ ಬರಿಬೋದು. Correct, so hope you all know Pythagoras theorem. Correct, OS square is equals to ON square plus SN square. Okay, hypotenuse square is equals to the sum of the squares of the other two adjacent sides, right? So ಈಗ ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ, OS square I'll keep as it is. ON ಅಂದರೆ ಏನಂತ ಬರಿಬೋದು, I'll just write here ON is nothing but OP plus PN. Correct, so I'll put that here, OP plus PN whole square ಇದೆ plus SN square. So ಈಗ expand ಮಾಡೋಣ, OS square is equals to OP square plus PN square plus 2 times of OP plus PN, that is A plus B whole square is equals to, so ಏನು ಬರಿತೀವಿ, let me just write here, ಏನು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ, A plus B whole square is equals to A square plus B square plus 2AB. ಅದನ್ನು ಯೂಸ್ ಮಾಡಿ I have expanded OP plus PN whole square as OP square plus PN square plus 2 times of OP plus OP into PN. Okay, plus this SN square as it is. Okay, is that clear? So ಈಗ ಇಲ್ಲಿ ಮತ್ತೆ ರೀಗ್ರೂಪ್ ಮಾಡೋಣ, ಏನು ಮಾಡ್ಬೋದು, ಸೊ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ OS square is equals to, so OP square I'll keep as it is. Okay, ಪ್ಲಸ್ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇನ್ನೊಂದು ಟ್ರಯಾಂಗಲ್ ತೊಗೊಂಡ್ರೆ ದಿಸ್ ಒನ್ SPN ಟ್ರಯಾಂಗಲ್. ಓಕೆ, ಇನ್ ಟ್ರಯಾಂಗಲ್ SPN ಏನು ಹೇಳ್ಬೋದು, ಅಗೇನ್ ದಟ್ ಈಸ್ ಅ ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲ್. ಕರೆಕ್ಟ್, ಸೊ ಐ ಕ್ಯಾನ್ ಸೇ ಲೈಕ್ PN square plus NS square is equals to PS square ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ ಈಗ ಅಲ್ಲಿ ಗ್ರೂಪ್ ಮಾಡಿದ್ರೆ ಆ ಥರ, ಸೊ ಯಾವುದು PN square plus SN square is nothing but NS square is nothing but PS square ಅಂತ ಬರಿಬೋದು. ಕರೆಕ್ಟ್, ಸೊ ಐ ಕ್ಯಾನ್ ಸೇ OP square plus PS square plus 2 times of OP into PN. Okay, so ಇಲ್ಲಿ again OP ಅಂದರೆ ಏನು, that is very clear, magnitude of A vector. PS ಅಂದರೆ ಏನು, this is our PS which is nothing but equal to magnitude of B vector ಆಗಿರುತ್ತೆ. Okay, and then again ಇಲ್ಲಿ 2 times of OP is nothing but A, and PN ಅಂದರೆ ಏನಾಗಿರುತ್ತೆ, so again we will consider the triangle PNS triangle. ಸೊ ಅಲ್ಲಿ cos theta ಬರಿತೀನಿ, ಏನು ಬರೆಯೋಣ, cos theta ಬರೆದ್ರೆ adjacent by hypotenuse, right? cos theta ಹೆಂಗೆ ಬರೀತೀರಾ, adjacent side by hypotenuse. ಸೊ ಇಲ್ಲಿ adjacent side ಯಾವುದು, theta ಇಲ್ಲಿದೆ, PN is the adjacent side, correct? ಸೊ PN by hypotenuse ಯಾವುದು, PS. ಓಕೆ. ಸೊ ಈಗ ಪಿ ಎನ್ನ ಏನಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು, ಪಿ ಎಸ್ ಕಾಸ್ ಥೀಟಾ. ಬಟ್ ಪಿ ಎಸ್ ಐ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್, ಪಿ ಟು ಎಸ್ is nothing but B vector. So I can say Pn as B cos theta. So ಈಗ ಎಲ್ಲವನ್ನು ಒಟ್ಟಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. OS is nothing but our resultant vector, correct? So I'll just write here OS ಅಂದರೆ resultant vector, r square ಅಂತ ಬರೀಬೋದು ಪ್ಲಸ್, ಕರೆಕ್ಟಾ, r square. Then OP square andre enu, so OP square is nothing but A square, so this is like R square A square, and PS square andre enide namge, PS is nothing but B, correct? So this is like B square, 2 times of A into Pn andre I can substitute B cos theta. So all together next page alli baritini, so enagatte R square is equals to A square plus B square plus 2ab cos theta agate. This is r square, but we want the magnitude of r, that means square root tagondre en barutte, r is equals to square root on both the sides, enagutte square root of a square plus b square plus 2ab cos theta. Okay, so this is going to give us the magnitude of resultant vector. Yes, so this is going to give us the magnitude of resultant vector. So ಏನು ಮಾಡಿದ್ದೀನಿ, I just have substituted for everything. Okay, so here, so illi OS is nothing but r square, so r square is equals to a square plus b square plus 2a into Pn ide, Pn andrenu B cos theta ide. So what we finally got is r square is equals to a square plus b square plus 2ab cos theta. Okay, so this is the expression for resultant of two vectors. Okay, any doubt till here? It's just, you know, the basic logic is from the parallelogram law of vector addition. Along with that, we just have used the Pythagoras theorem everywhere. Okay, and one simple trigonometric substitution, that is Pn can be written as B cos theta. Okay, this Pn is B cos theta. Okay, so that is what we did. Is that clear? And similarly, can someone tell me, you know, what is this Sn? So Sn ana ಏನಂತ ಬರಿಬೋದು ಅಂತ ಹೇಳ್ತೀರಾ? Can someone try? Sn can be written, okay, let me just go to first diagram here itself. So Sn ana ಏನಂತ substitute ಮಾಡ್ಬೋದು ಅಂತ, can someone tell me? Because Pn ನಮಗೆ ಗೊತ್ತಾಯಿತು, that is nothing but B cos theta. Again consider the triangle SNP, triangle SNP consider ಮಾಡಿ, hint ಏನು, sin theta ಬರೀರಿ. So sin theta ಏನಾಗುತ್ತೆ SNP ಅಲ್ಲಿ, opposite by hypotenuse ಆಗಿರುತ್ತೆ. Okay, opposite by hypotenuse. So opposite side ಯಾವುದು ಅಲ್ಲಿ SN, by hypotenuse ಯಾವುದಾಗಿರುತ್ತೆ PS ಆಗಿರುತ್ತೆ. Again PS is nothing but our vector B, correct? So B vector or ಅದರ magnitude ಆಗಿರುತ್ತೆ. So I can say Sn is equals to B sin theta. Okay, so Sn is equals to B sin theta. Okay, so from this we can actually get the direction of the vector. Okay, from this we can get the direction of the vector. Again what I will do, I will consider the same triangle SPN and I will write down the tan theta to get the direction, of the resultant vector. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡೋಣ, so I will say, yeah, I just want to change the color. So the direction of the vectors. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, alpha is the angle between r vector and a vector. Correct? ನಮ್ಮ diagram observe ಮಾಡಿದ್ರೆ so ಏನಾಗಿದೆ, alpha is the angle between our a vector and the resultant vector ಇದೆ. ಸೊ ಈಗ tan alpha ಬರೆದ್ರೆ, ಓಕೆ, ಸೊ ಏನು ಹೇಳ್ಬೋದು, tan alpha, if I write down tan alpha, ಸೊ ಏನಾಗಿರುತ್ತೆ, ಈ ಡಯಾಗ್ರಾಮ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, alpha is here, opposite by adjacent, ಅಂದರೆ SP by, or okay, we have to consider the right angle triangle, OSN triangle, okay, ಯಾವುದು we are considering OSN triangle, okay. So in the triangle OSN, okay, tan alpha ಅಂದ್ರೇನು, opposite by adjacent ಆಗಿರಬೇಕು. ಸೊ ಅಲ್ಲಿ ಆಪೋಸಿಟ್ ಸೈಡ್ ಯಾವುದಾಗಿರುತ್ತೆ, SN ಆಗಿರುತ್ತೆ, ಡಿವೈಡೆಡ್ ಬೈ adjacent side ಯಾವುದಾಗಿರುತ್ತೆ, ON ಆಗಿರುತ್ತೆ. ಸೊ ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಗೋ ಬ್ಯಾಕ್ ಟು ದಿ ಡಯಾಗ್ರಾಮ್. ಸೊ ಏನಾಗಿದೆ, here we have OSN triangle ತಗೊಂಡ್ರೆ, ಓಕೆ, OSN triangle ಅಲ್ಲಿ ಆಪೋಸಿಟ್ ಸೈಡು SN, adjacent side ಯಾವುದಿದೆ ON, ಓಕೆ. ಬಟ್ ON ಅನ್ನು ಏನಂತ ಬರಿಬೋದು, OP ಪ್ಲಸ್ PN, ಕರೆಕ್ಟ್. ಸೊ ಏನು ಬರಿಬೋದು ಇಲ್ಲಿ, SN will keep as it is, ON ಅನ್ನು OP ಪ್ಲಸ್ PN ಅಂತ ಬರಿಬೋದು, or this is again going to give us tan alpha is equals to, so SN ಅಂದರೆ ನಮ್ಗೆ ಬಂದಿದೆ ಆಲ್ರೆಡಿ, ಏನದು, SN is nothing but B sin theta, correct, and OP is nothing but A, okay. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, SN ಅಂದರೆ B sin theta divided by OP ಅಂದರೆ it is nothing but the magnitude of A vector plus PN ಅಂದರೆ already we have found out, that is nothing but B cos theta. So I will substitute that, B cos theta, okay. So this is going to give us the direction of the resultant vector. So ಇದೆರಡೂ ಫಾರ್ಮುಲಾ ನಿಮಗೆ ಇಂಪಾರ್ಟೆಂಟ್, ಓಕೆ. ಸೊ ರಿಸಲ್ಟೆಂಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಫಾರ್ಮುಲಾ ಏನು, a square plus b square plus 2ab cos theta under root, ಇಲ್ಲಿ theta is the angle between a and b, that is important. theta ಅಂದರೆ ಏನು, ಇಲ್ಲಿ angle between a and b, vector a and vector b, whereas alpha is the angle between resultant and a vector, okay. Direction of the vector na hege bariತೀರಾ, so we usually express it in terms of angles, right. So tan alpha is equals to B sin theta divided by A plus B cos theta agate, okay. So this is one important question for 5 marks, this derivation, okay. Is it clear? Any doubts? Yeah, any doubts? Yeah, I hope it is clear till here to everyone. Please remember these two important formulas which we will be using in all our upcoming classes, okay. It's not just limited for this chapter, it's important for all other upcoming classes, okay. So I think you can just wind up at this point. If you have any doubts, please ask, or else I'm just going to end the session for today. Any doubts? Yeah, okay, I think I can end here. Have a good day ahead, take care.